Hi, today we're going to be talking about factoring trinomials. So we're going to factor trinomials in the form of x squared plus bx plus c. Notice that there is no number in front of this x squared. That is normally an a value. So it goes a, b, c. But there's no a value that we're going to be dealing with today. Later on in this chapter, we will deal with the ones that have a values, but not today. All right, so we're going to factor these. And the factored form of this trinomial is two binomials, x plus m and x plus n. Now, m plus n has to add up to be b, and m times n has to multiply to c. So we're looking for a combination that multiplies to this last number but adds up to the middle number. So like for this last one, what combination multiplies to 6 but adds up to 5? So 2 and 3. And those are the factors that we have, and we write it x plus 2 and x plus 3. It'll get more difficult when we have an a value in the front here, but for these are pretty simple because we're just looking for that combination that works. And when we find that combination, we can go ahead and write our answer. All right, so let's try one of these. We have a bunch of different possibilities with b and c, whether or not they're positive or negative, so we're going to run through them. So here we're looking for two numbers that multiply to 12 but add up to be 7. So again, they use the word sum and product, which are just the mathematical terms for adding to and multiplying. So we're going to make a little chart here. Factors of 12 that add up to be 7. Now you might already know what the group is, and that's fine. That's great. If not, you can go ahead and just start. You start with 1. 1 and 12, well, that adds up to be 13. That's not 7. All right. Then you try 2. Well, 2 goes with 6 to 12, which gives us 8. And then you go with 3. Oh, wait, that's the one we want. That's the one that's 7. Now, if you can think of those beforehand and just go straight to it, great, do that. You don't have to write out this whole table. But if you don't, you can start writing off this table, and that will help you start with 1, then try 2, then try 3. And the next one would have been 4, but I already have 4 on my table, so I know I'm done. It's got to be one of these 3 combinations. So to go ahead and write that, I'm going to use the 3 and 4 in spots for m and n. And so my answer is x plus 3 and x plus 4. And again, if you Punnett square this out, you're going to go ahead and get that original value that we had here. We're just doing this opposite. So we can check it by multiplying it out. See what they're going to do. They're going to FOIL it instead of using the Punnett square, which is fine. And we multiply it out, and we get that exact same answer we started with. All right, so let's try another one. So now we're multiplying two things to multiply to 2 that add to be 3. Well, to multiply to 2, there's only one combination, 1 and 2. 1 times 2 multiplies, and it does equal 3, so that's our combination. Now, notice they wrote it as x plus 2 and x plus 1. If you want to write it as x plus 1 plus x plus 2, that is fine. They can switch spots. That is not a problem. All right, now we have a negative 12 here and 27. So how do we multiply to positive 27 but add it to be negative 12? Well, in this combination, when it's negative and then a positive, you're going to have to use your negative values. So what do I mean? Negative 1 times negative 27, that still multiplies to 27. So, but they do add up to be a negative number. That's how we get that negative number in here. So 1 and 27, well, that's 28, not 12. All right. 3 and 9, well, there's our combination, 3 and 9. So now we can write our answer, x minus 3 and x minus 9. Again, you can go ahead and check it and multiply it out. You can even go ahead and do a graph if you wanted to. And if we did a graph, this is on a graphing calculator. You'll get to use those junior year or in Algebra 2. And notice it crosses at 3 and it crosses at 9. So those are things that we've learned already. But if you didn't want to go ahead and graph it out, you would notice that also. All right, here we go again. We want to multiply to 16, then add up to negative 10. So we're going to go ahead and write our combinations out, negative 1 and negative 16, then negative 2 and negative 8. Oh, that's negative 10 already. And again, they're negative because I have a negative and then a positive. The only way to multiply to get a positive is multiplying two negatives together. All right, what about this one? Now notice it's a plus and then a minus. Whenever this last value is negative, one's going to be negative, one's going to be positive in terms of my factors. So here's negative 18, and we're trying to add up to be 3. So negative 18 is 1 and negative 18, or negative 1 and 18. Notice we have to take into account both of them. One will give us a negative, one will give us a positive. But we're going to try to add up to be 3. That's neither one of those is 3. So then I try 2. Well, that's closer. I would also try negative 2 to get the positive value. Then I'd try 3. Does 3 go into 18? Yes, it does, 6 times, and there's my negative 3. But we wanted positive 3, right? Yeah, going back, we wanted positive 3. So we have to try that other combination, negative 3 and 6. And so we write x minus 3 and x plus 6. So again, all this is looking for is our factors, which to multiply to give me the last number, but add up to be the middle number. So that's the combination that works, and that's the combination we write down. Going again, we have negative 20 here, but add up to be negative 1. So we got to multiply to negative 20, but add up to 1. So 1 and 20. Well, the other one is 19. 2 and 10. Nope. Or positive 8. 4 and 5. Notice we skipped 3. Why? Because 3 doesn't go into 20. We got to 4. So this has got to be it because 5 is the other answer. So it couldn't have been anything else. So here's our negative 1. If you have negative 4 and 5 is positive 1. We want this one right here, this combination here. And so then we write it as plus 4 and minus 5. Multiplying to negative 5, that adds up to be 4. Well, there's very few combinations, just 1 and negative 5. But I want the positive 4, so I want negative 1 and positive 5. Going to 24. 1 and 24, is that 23? That's not going to work. 2 and 12 is 10. Nope. 3 and 8, that's 5. And which one do we want? We want the negative 5, so it's this one, 3 and negative 8, which is obviously what we have for D. And that's what I have for you today.